Hello, we're Team My Robotic Neighbor for Asbua Science Club.
The performance is inspired by the movie My Neighbor Totoro, released in 1988. When we were designing the robots, we thought it would be the best to make them small so they could be easy to transport. To get the proportions right, we chose to create two puppets that we humans control instead of acting ourselves.
Let us tell you how the show is structured.
The lines with different color represent each robot's path. The pink color indicates all the interactions between the humans with robots and robots with robots. The cat bus activates Totoro by a distance sensor. Totoro then follows the path and later activates the blue friend and white friend by distance sensors. When the spirits have crossed the red line, the distance sensor for the tree then waits for the humans to also activate a distance sensor that belongs to the tree to activate the pump.
Totoro, along with the other robots and the human, activate the air pump using two distance sensors, one on the human side and one on the robot side. Both sensors must activate for the tree to inflate. If one doesn't detect presence, the other one won't activate the tree pump. Totoro, along with other robots, follow a line using color sensors. But when they detect a red line, they stop following a line and go into a free roaming state, where they place themselves around a tree and start dancing. Both the blue and white spirits use distance sensors to monitor their surrounding, to not bump into each other, for example when they're following Totoro in the line and other things and humans on the stage. All robots except the tree use gyro sensors to maintain stable driving, both while moving in a straight line and turning. We use this because some of the robots have an unstable body.
Catbus is now equipped with front-wheel drive and two sliding plates with rounded edges at the back. This design allows the robot to move smoothly across the floor without getting stuck. The rounded plates reduce friction and distribute the weight effectively, making the robot stable and reliable. The Catbus uses gyro sensor, distance sensor and two motors.
This is the white spirit. At the front it has two wheels with motors and balls at the back attached in these blue things. The balls reduces friction and makes it able to turn. At the front it also has two light sensors which can see the colors on the ground and therefore it can follow a line. On the top here it has a distance sensor which makes it see other robots so it can interact and move swiftly without hitting stuff. This is a gyro sensor which we use to calculate our turning and make it precise, and over here we have a scissor lift using a motor back here which pushes a column forward to make this lift go up.
This is Totoro's blue friend, and it has three spike motors, two light sensors, and one distance sensor. It uses a mechanism that makes so his arm moves up and down.
The pump robot has two distance sensors that it uses to activate a motor. The motor activates a push sensor. For the tree to inflate, both distance sensors have to be activated. For them to trigger, the dolls, that are the human, and the robots that in the installation have to pass by the distance sensors. Once activated, they activate a pressure sensor that causes the tree to inflate.
This is Totoro. We have detachable ears to make him easier to transport, and this is the arms. In here is a simple connection to one of the engines inside, which both sides have. On this arm, you have a magnet where you can attach the seat bag that he gives to one of the girls. And you have a distance sensor, which is attached to one of the hubs inside. Now, we can remove his head, but he has a distance sensor in front, which I forgot to take out, which he sees the cat bus with and makes him able to go onto the black line. There's the distance sensor, and this is the inside of Totoro. Here you see a color wheel, which is very particular. It uses this to communicate between the two hubs of this robot. Since we can't communicate in any other way due to the rules, we use this color wheel to send a signal from this. So we have four different colors that we send to a sensor inside here, so the two hubs can communicate with each other, because we simply did not have enough ports to send signals to all our engines, so we needed to use two hubs. This is the arm hubs, which you see here. You can connect with two different pieces. This is simply to make the connection better. You attach this to the hub, and then you attach this like so, and it should stay on, but get support from Totoro. And then right here we have the two hubs, which have all the connections with the robot. And this is the underside, where we have right here you can see 3 color sensors, 2 of them connected to the bottom hub and 1 of them connected to the top hub. These 2 are used to follow a line and see the red color on the ground, and this is also used to see the red color but not to follow the line. Here we have 4 motors for 4 wheels, each 2 motors on each side, because Totoro is still very heavy and therefore needs all the support he can get. So we use 2 engines to make him move forward, and here we use the balls once again to make him move swiftly and ease in the friction. Here we use steel balls because they are smoother and therefore moves along the ground nicely.